Hi, everyone. Welcome and thank you for being here today. Today, we're going to be presenting Waypost, an open source feature flag management platform that specializes in A/B testing. So my name is Julia, and I, along with my colleagues, Sean and Caleb, have spent the last couple of months creating Waypost. I'm going to start us off by giving an overview of the problem that Waypost solves and the kind of organization that will run into this problem. And then I'll go in depth into the topics of A/B testing and feature flags and the solutions for implementing them. And after that, I'll go over the pros and cons of each solution. Next, Sean is going to explain how we designed Waypost to solve the problem for our use case, and he'll also give a demo of how to use Waypost. Lastly, Caleb will talk about the engineering decisions and discussions we went through while designing Waypost. And finally, we'll open the floor to any questions. Throughout this presentation, we'll be using the terms feature and new feature a lot. We define feature as a distinguishing characteristic of a software item like performance, portability, or functionality. So a new feature can be thought of as some change to the functionality of an application, whether it's an additional feature or just an upgrade to an existing feature. This could be small and simple, like a UI change, or something big and complex, like a new algorithm or way to log in. As development teams create new features, they'll want to have confidence that their design decisions benefit the business. This means that they'll need to make data-driven decisions. To do this, they'll need to analyze the behavior of their application's users to gain insights on whether their design choices are helping, hurting, or having no effect at all. This means that the team will have to run experiments that consist of serving their users two versions of the application, the new one and the existing one, and collect data from both versions. Waypost allows developers to use feature flags to deliver two versions of their application. They can run experiments and view the results to help make informed decisions. And if a new feature has bugs or performance issues, they can easily toggle it off. Now, to demonstrate why an organization would use Waypost, we'll take a look at a hypothetical solar panel company called SolarFlare. One way SolarFlare generates sales is through a feature that estimates how much money a solar panel installation costs. Currently, customers do this by entering information into a form and then hitting calculate. But after collecting user event data on this process, the SolarFlare dev team discovers that 80% of people who start filling out the form never finish. It's theorized that the reason for this is that filling out the form is too tedious for customers. To increase the odds that a user submits the form, they design a new version which utilizes third-party software to calculate the quote. This software only needs the user's address and uses satellite and climate data to make the calculation. To know whether the new feature helps more customers complete the form, they'll need a way to measure the difference between the old form and the new one. Let's see how they can do that. One option is to roll out the new feature temporarily and measure how the metrics change, but there are several problems with this. One issue is that our new feature hasn't been tested in production and could have bugs, so we don't want it rolled out to everyone at once. Another important problem is that it doesn't control for external factors like time. For example, users may be more likely to sign up at different times of the year. Without controlling for external factors, the change in metrics might be attributed to the new feature when it was actually caused by something else. Therefore, we need to make sure the only difference between the two user experiences is the different feature being served to them. To do this, we'll have to show both features during the same time period and randomize who gets which feature. Turns out that the solution we're looking for is experimentation, also known as A/B testing. Let's now explore the concept of A/B testing and its challenges. A/B testing is a common method used by product development teams to test the impact of a new feature. It's experimenting with two or more versions of a feature at once by randomizing who gets which feature. Typically, you'd show 50% of users version A and 50% of users version B. Then compare some metrics between the two groups. You then determine whether there was a significant difference in the metric and how much the difference was. We can use this information to make a decision on whether to ship the new feature, keep experimenting, or stick with the old version. And just a quick note, we'll be using the terms A/B test and experiment interchangeably going forward. Now, despite being extremely useful, A/B testing comes with several challenges. First, we have to figure out a way to randomly assign users into a group and at the desired proportion. Then, we have to keep track of which group the user is in for each experiment so that they're getting a consistent experience. After the user gets exposed to an experiment, events have to be logged. In the solar flare example, we're interested in the form completion rate. So we need to log each time a user opens the form and when the user completes the form. Once the experiment is finished, we need to analyze the results somehow. This entails calculating the metrics from the user event data. We then need to perform some statistics on them to determine if the experiment was successful or not from a statistics standpoint. As it stands, there are quite a few steps involved in performing A/B testing. Later, we'll dive into some solutions that companies currently use. Before we can dive deeper into how we can analyze experiments, we need to first figure out how to implement the 2 or more versions of a site. The best way to do this is using feature flags. So what are feature flags? A feature flag is a toggle that turns functionality on or off without needing to redeploy. There will typically be a tool that allows developers to toggle the feature flag. In the app's code, it's implemented by writing a conditional statement that evaluates the current status of the flag and wrapping the code for one feature in the true condition while wrapping the code for the other feature in the false condition. In the case of solar flare, they would render the new form if the conditional returned true, and they'd render the old form if the conditional returned false. This is perfect for our A/B testing use case. As you can see, a company like Solar Flare would want to use feature flags to help them do A/B testing. Let's look at how they would implement this. First, they'll want to start with a database to hold the feature flag data and a server that handles queries to the database. They'll also need a front end so that developers, as well as non-technical people like product managers and marketers, can easily view and manage feature flags using a UI. But right now, the application will have to query the database whenever a flag is encountered in the code, which isn't very scalable. So we need to store the flag data in the app and only update it when needed. So we'll need a way to share flag updates to the app so that if a flag is switched off, users will no longer get the feature. This will require something like an SDK, which is like a library of code that's imported into the app. The SDK will communicate with the backend server to receive up-to-date flags. That's the bare minimum for feature flags, but this still doesn't enable us to do A/B testing. Before we talk about implementing A/B testing with our feature flag app, we'll need to clarify one term we'll be using, which is user event data. We will refer to user event data as any data collected about users' interactions with a website or app. Whenever a user visits a site, they're identified with an ID like a session ID or user ID. Whenever they interact with the site, data is collected to generate metrics which then get analyzed. User events can consist of pretty much any action, but some examples are page views, clicks, signups, purchases, purchase amount, time spent on a page, etc. So continuing where we left off, Solarflare now wants to add A/B testing capabilities on top of their feature flagging platform. So user event data needs to be collected from the client and sent to a database with a data pipeline. After we have the data in the database, we'll need to calculate the metrics like completion rate and run statistics on them. This can be done on the backend server we already have or on a separate one. After that, the front end should show the results to the developer. This is just the bare minimum architecture that a team would need to build and will likely need way more components to handle scaling. Instead of building your own platform, there are also third-party services that you can use. We'll go over the pros and cons of each. Building your own platform comes with many benefits, such as having full control over the feature set and being able to customize it exactly to your needs. This gives you the flexibility to deploy it however you wish. It also allows you to keep your data in-house. However, the trade-off is that it takes a huge amount of time and resources to build the entire platform from scratch, and you have to rely on your own infrastructure. And as the ones who created the system, you will also be the ones responsible for maintaining it into the future. So it's a huge commitment. The other option is to use a third-party feature flagging platform that handles the engineering aspects for you so that your team doesn't have to invest time into building and maintaining the system. Some well-known players are LaunchDarkly and Optimizely, which are both feature-rich and reliable. Since they were created by industry experts, you can typically trust that they're reliable and work correctly. They'll also take care of the maintenance and save your team time and resources. However, these can cost a monthly fee and can be out of budget for smaller companies. They're also less flexible in terms of customization than an in-house platform and can end up being a black box where the developer doesn't know exactly how it works. Also, since third-party services usually aren't self-hosted, That means they'll be storing your data, which not everyone might be comfortable with. If Solar Flare was a bigger company with more engineers, then building their own system would be a good option. And if they wanted a large set of features quickly and had a larger budget, then a paid solution like LaunchDarkly would be a good choice. But right now, the DIY option costs too much time and resources, and the paid option is too costly and inflexible for them. They also don't need many extra features. They just need to run some simple experiments. So we saw the opportunity to create a feature flagging platform that fits the needs of a small business like Solar Flare. Waypost is self-hosted and open source, so it's completely customizable while still containing the core features our target user needs. Now I'm going to hand it over to Sean, who's going to talk about Waypost architecture.
Thank you, Julia. Now that we know how Waypost addresses our use case, let's find out more about Waypost and its architecture. First, we'll give an overview of Waypost architecture and how to deploy Waypost using Docker. Afterwards, we'll talk about the individual components of Waypost and the roles they play in the overall architecture. Lastly, we'll explain and demonstrate how Waypost allows developers to perform A/B tests on their applications. This is the full view of Waypost architecture. I know this is a lot, but don't worry. We're going to go in depth into each of these components, how they interact, and how they help our target user manage their feature flags and run experiments. As you may notice, we have two colors here, red and blue. The blue components are part of Waypost architecture, while the red components are something that you, the developer, are responsible for creating. Starting on the left here, we have our manager application. It's a full stack application that's responsible for managing feature flags and experiments. The manager app sends copies of the flag data to the flag provider, which saves the copy and forwards it to each application running the Waypost SDK. The SDK, which is embedded into your application, is responsible for evaluating flags at runtime, and thus allowing you to serve multiple versions of your website to your users. Using your existing user events logging solution, your application sends user events to an events database. And when you're done running an experiment, the manager's backend will query the events database. It'll run statistical analysis and then display the results in the UI. Now I'll show you how to deploy Waypost with Docker. First, you're going to want to clone the Waypost Docker repo on GitHub. Then you'll run our Docker Compose file, which will boot up instances of the manager app and the flag provider. Then you'll want to install the SDK into your existing application. And afterwards, you'll want to provide it with the address so that the flag provider and the SDK can connect. We'll begin our component deep dives with the manager app. The manager application is a full stack application made up of three components: a UI, a backend server, and a PostgreSQL database. It provides a store of your feature flags and allows you to create, update, and delete them. It also allows you to start and stop experiments, run statistical analysis, and display the results. And it provides updated flag data to the flag provider. Now I'll show you how to manage your feature flags in the UI. This is the flags dashboard. You'll be shown this page when you first visit the manager app. You can return here at any time by clicking the flags dashboard button located on the nav bar. This dashboard displays all the flags being used by your application. From here, you can toggle and delete flags. If we click Create New, we can enter in information for a new flag. When creating a new flag, the most important thing to do is to give it a descriptive name. The rest of these fields are optional. To view a flag's details, you can click its name on the flag's dashboard. This page allows you to view its details, like description and rollout percentage, and edit the flag. This is our flag events page, which shows you when any flag was created, edited, or deleted. This page is particularly useful for keeping track of the changing state of all your feature flags and has a drop-down menu that allows you to filter events by flag name. As we mentioned before, the SDK is responsible for evaluating flags. So it's important that the SDK has up-to-date flag data. But why then do we not just connect the Manager app, which stores the flag data, directly to the SDK? This architecture could send updates in real time, but it's not very scalable because the specific functionality of managing SDK connections is intertwined with the flag manager's other duties. Scalability is important in this case because the number of applications running the SDK can fluctuate significantly. For this reason, we created the Flag Provider, a service that's lightweight, scalable, and can send updates to the SDK in real time. So how does the Flag Provider serve real-time updates to the SDKs? Whenever there's a change made to the flag data, the Manager application sends an HTTP request called a webhook with the updated flag data. The Flag Provider then saves that to its memory and forwards the data to the SDKs using server-sent events, or SSE connection. And then the SDKs save the up-to-date flag data. Later in this presentation, we'll take a closer look into the specifics of how server-sent events and webhooks work and the reasons we chose to use them. The SDK is a package that's installed into your application. It stores a copy of the flag data, and it is responsible for evaluating flags to help you render multiple versions of your application and place users in experiments. We currently have SDKs for React on the client side and Node on the server side. You can install an SDK into your app using npm. We'll now walk you through how Waypost SDKs render multiple versions of a website for server-side and client-side applications. For server-side rendering, first a developer installs Waypost Node SDK into their application. A request comes in. The SDK evaluates flags as the application renders the site. Then the page is sent in the response. For client-side rendering, the developer installs Waypost's React SDK into their application. The request comes in, and the React app is served to the client. The React app runs on the client, and the SDK evaluates flags as the React application renders the page. We know that the SDK is responsible for evaluating feature flags, but what does it need to consider when evaluating? The most obvious thing would be the flag status. But what if you only want your flag to be on for some users? And how do you ensure a flag evaluates consistently per user so they don't get served different versions of your application if they leave and come back? To address these concerns, Waypost passes in a user ID into a hashing algorithm to determine how to evaluate flags with rollout percentages. Waypost itself doesn't assign the user IDs. That's your responsibility as the developer. However, Waypost will work with any user ID system as long as each ID is unique per user or visitor of your application. Some examples are a visitor's IP address. If you have a login system, you can store one's username in a session, or if you store a random string in a cookie when someone visits your website for the first time. Now that we have a user ID system, we can consistently serve the same features to users when they revisit your web application. But what if we want to customize how a flag evaluates for specific users, like for a beta tester? You would want to make sure that they receive the new feature so that they can test it. Waypost accomplishes this with its custom assignments, allowing you to customize how a flag evaluates for specific user IDs. Here's an example of 3 custom assignments on the quote form flag. With these set up, the flag will always return true and show the new version of the quote form for users Julia M and Caleb RS, while Sean R will always be shown the old version of the quote form. Here's how you can view and edit a flag's custom assignments in the Manager App's UI. Waypost evaluates flags based on the following flag data attributes. The flag status, a Boolean value that's either true or false. custom assignments, a list of user ID and status pairs, and a rollout percentage, a number that determines what percentage of users get the new feature. Now I'll show you how the flags are evaluated with an example. First off, we have a feature flag in our React component. If evaluate flag returns true, then the new quote form will be rendered. But if it returns false, then the old one will. The evaluate flag method comes from the SDK client object. This object also stores the flag data and the user ID and uses both data points to evaluate a flag. In our example, someone visiting Solarflare's website is assigned a random string as their user ID. To determine which version of the form they'll be served, first we must check the flag status. Since the flag status is on, we go right. Now we check if the user ID matches a custom assignment, which overrides all other logic. We don't have a custom assignment for this user, so we go left. Now we see if the flag isn't being rolled out to everybody. It has a rollout percentage of 50, therefore we go right. Now we hash the user ID, and we get 55. 55 is greater than our rollout percentage of 50, so we go right. Evaluate flag returns false, so the old quote form is shown. To integrate your application with the Waypost SDK, you first need to generate an SDK key. You then need to copy the key and insert it into your application. This SDK key will be used to verify connections between the flag provider and the Waypost SDK that's in your application. Now I'll show you how to integrate your React app with Waypost's React SDK. Before adding any feature flags to individual components, we first have to add some code to your top-level app component. First, you'll want to import config and Waypost provider from the npm package. Next, call the config constructor, passing in your SDK key and the address of the flag provider service. This will return a config object. Then, inside of your main app component, wrap everything in the return statement inside of the Waypost provider component, which was imported from the SDK. You'll need to pass in the config object as a prop. With this set up, the rest of your React app can access the SDK client and its methods using React context. Now, whenever you want to serve a feature flag in your code, or whenever you want to serve a feature in your code using a feature flag, you'll want to add the following code to the relevant component. Import Waypost context from the npm package, then instantiate the SDK client object using React's useContext hook. Call its evaluate flag method to get the status of a flag, passing in the name of the feature flag, which was set up in the UI, and a default value to return if the data isn't available for some reason. You can then use this Boolean to return one feature or another in your code. Now we'll get into running experiments with Waypost. First, I'll show you what components and event tracking must be set up before experimenting. Then I'll demonstrate how to set up an experiment in the UI. And last, I'll detail how Waypost helps you determine when to end your experiments, how to run statistical analysis, and view the results. To run experiments with Waypost, an organization must already have their user event data stored in a PostgreSQL database, which we refer to as the events database, and they must give read access to Waypost. The developer must send data from their application to this database each time a user is exposed to an experiment. In addition, they must also send data each time a user performs an action that the developer wants to measure for an experiment. An example of this would be when a user signs up for a quote. Before starting an experiment, the developer must connect the Manager app to the events database. Then they must create the metrics they want to measure. And finally, they can create and start the experiment on one of their flags. Now I'll demonstrate how to set up your experiments in the UI. The first thing you must do to perform experiments is connect the Manager app to your events database. This button will tell you whether you're connected or not, and allows you to connect or disconnect depending on your current connection status. Now, you'll input the credentials to connect to your events database. In addition, you have to provide a query string that Waypost will use to query your events database for data pertaining to the experiments. This query must return a table with 4 columns named experiment ID, user ID, timestamp, and treatment. Once you click submit and the Manager app verifies the credentials and query, your connection will be saved. Before you create an experiment, you must set up some metrics that will be used to determine whether your experiment was successful. To show you how to do this, let's visit the metrics page. You can open the new metric form like so. There are 4 types of metrics to choose from, which you can read more about in our docs. Just like the database connection, Waypost needs a query string to query your database for the analysis. We include specific instructions on what columns the query must return over here. Once you set up the necessary metrics, you can create an experiment on a flag. From the Flags dashboard, click on the flag you want your experiment to run, and then click Create Experiment. The percent of users tested will determine what percentage of your users will be placed in the test group and receive this new feature. You can also set a duration for the experiment, but note that Waypost will not automatically be stopping your experiments. Lastly, you can select the metrics that you want on the experiment. Then just click Start New Experiment and your experiment will be set up. We now know how to set up an experiment with Waypost, but after you start one, how do you know when to stop it? The most common way is to wait for enough people to be exposed to an experiment, since the more people in an experiment, the more likely you can trust your results. That's why the Manager app provides regular updates on the amount of users exposed to an experiment. The Manager app accomplishes this with this exposures pipeline. This pipeline runs once every night to aggregate the amount of users bucketed into each cohort of the experiment, and it stores this aggregated data into a table in the Manager app's database. This data then gets displayed on the front end as a line chart, essentially depicting the sample size of each cohort over time. The developer can use this chart to determine how much longer the experiment should run. Once the developer is ready to end the experiment and view the results, they can click on the Refresh Results button on the Manager app's UI. This triggers our statistics pipeline, which queries the events database for the metrics being tracked for this experiment. It then analyzes this data using statistical tests, using different tests depending on the type of data. If all goes successfully, it stores the results in the Manager app's database, which will then be displayed in the UI as a table, with 1 row per metric attached to the experiment. The most important column on the results is the p-value, which will tell you if the difference in your metrics was caused by the new feature or if it was more likely caused by random chance. This value lets you know if the new feature was successful in changing user behavior. Now I'll hand it off to Caleb, who will talk about some of the engineering decisions we made while designing Waypost.
Designing and building Waypost came with a number of engineering challenges. The major challenges we faced were communication between Flag Manager and Flag Provider, communication between Flag Provider and SDK, and how to efficiently run statistics. First, we'll discuss the communication between the Manager app and the Flag Provider. To understand why we need communication between the 2 services, it helps to understand why we need the Flag Provider in the first place. In the earliest implementation of Waypost, the SDK clients connected directly to the Flag Manager. However, there are 2 main issues with this approach. First, Waypost's API would need to handle 2 major functions: handling requests from the SDK clients and also handling API requests from the Flag Manager UI. The sheer volume of requests creates a potential bottleneck that could have adverse effects on either the clients or the users interacting with the feature flag manager. Second, services must now scale up together instead of separately. Because the number of external users is likely much greater than internal users, it makes no sense to scale the two functionalities at the same rate. Due to these concerns, we decided to implement an intermediary service whose primary purpose would be to provide feature flag data to the SDK clients, essentially acting as a cache for flag data. We named this service the flag provider. The addition of the flag provider allows us to separate the functionality of providing clients with flag data from the functionality of managing feature flags. Also, by creating a separate service, developers can horizontally scale the flag provider if the volume of SDK clients is too large for just a single instance to handle. This also allows an organization to reduce latency to the SDK clients by creating new flag provider instances in availability zones closer to their users. The drawbacks to this approach are that we now have to perform maintenance on an extra component. This also adds to the architecture's complexity because now we have to move flag data twice instead of just once. We decided that the drawbacks of added maintenance and complexity did not outweigh the benefits of being able to scale the application for more clients. So now that we've established the need for the flag provider service, we need a way for the flag provider to receive updated flag data from the flag manager so that it can forward the data on to connected clients. There were three ways we considered doing this: through polling, a message broker, or webhooks. Polling is a method of communication that uses HTTP requests sent at a predefined interval. Here's how it would work if the request interval was 10 seconds. The flag provider sends a GET request to /flags. The flag manager immediately sends a response with all the flag data, and the flag provider saves the flag data to memory. The flag provider then waits for 10 seconds and then sends another GET request. Though polling is a viable and simple way to consistently share updates to the flag data, it comes with a few downsides. Many of the polling requests will be unnecessary traffic. For example, even if the flag data hasn't changed since the previous poll, a request will still be sent. Not only is this extra work for the flag provider, but also the flag manager, which has to process each request. Also, flag data won't update in real time. It will update every 10 seconds. You won't be able to quickly toggle a flag status in situations where it's beneficial to implement quick changes. Considering these trade-offs, we decided to look for a better solution for communicating between services. A message broker is a commonly used tool that allows services to communicate with one another. Without going into too much detail, a message broker exchanges information through a system of publishers and subscribers. Within the context of Waypost, here's how a message broker would work. In the event that the flag data is updated, a message containing the flag data is sent to the message broker. The message broker forwards the message to the flag provider, who then saves the flag data to memory. Here are the trade-offs to this approach. Communication between the two services will be event-driven and happen in real time. The message broker gives some degree of fault tolerance. If the flag provider goes down for some reason, any messages sent from the flag provider will be available once it's up and running again. It also eliminates the need to create API endpoints and instead uses the message broker. Despite the benefits, there are some trade-offs with this approach. First, this would increase the complexity of our architecture. We would now have another component we would need to maintain and secure. And second, message brokers can make debugging difficult as you now have to rely on its logs in addition to the other services. For these reasons, we decided to investigate webhooks as a possible solution. A webhook is an HTTP request that gets sent in response to an event. Here's how it works within the context of Waypost. When an update is made to the flag data, an HTTP request whose body contains the flag data gets sent to the flag provider. An endpoint on the flag provider receives the request and saves the flag data to memory. The flag provider sends back a 200 OK response to the flag manager. Two of the main benefits of this system are simplicity. All we need for webhooks to work is to add an endpoint to the flag provider and some middleware on the flag manager that sends a webhook when flags are edited. Also, this architecture becomes event-driven, meaning that communication happens in response to events instead of request-driven. Some downsides to webhooks in this scenario is that they are not necessarily fault-tolerant. If the flag manager application is unavailable for any reason, we could potentially miss any important updates to the flag data, which could disrupt the entire system. Also, using webhooks means we lose some control over the data flow between services. For example, if a huge amount of edits are being made to the flag data on the manager application, then the flag provider would need to handle a request for every single edit, potentially overwhelming the service. We ultimately decided that we were okay with these risks because we expect the amount of edits being made to flag data to be relatively small. Similarly, we also had to decide on the best way for the flag provider to send updates to the SDK. After the flag provider receives the flag data from the flag manager application, the data needs to make one final move to applications running the Waypost SDK. The communication between the flag provider and SDK is different from the communication between the flag provider and flag manager in two important ways. Communication is server to client instead of server to server. The amount of communication between the two components is much greater because now we're interacting with a production application which may have thousands of concurrent users. This means that the method of communication we choose must be able to support lots of traffic and also be able to communicate with users' browsers. There were two methods of communication that we considered to ensure that the SDK client has up-to-date flag data: WebSockets and server-send events. WebSocket is a communication protocol that allows bidirectional communication through a single TCP connection. Here's a simplified three-phase version of how the WebSocket protocol would work if we were to use it. During the first phase, an initial GET request with some special headers are sent from the client to the server. This allows the server to establish a connection using the WebSocket protocol. The second phase is when the client and server communicate with each other. Messages can be sent back and forth using the WebSocket connection. The connection is closed during the final phase when either the client and server call a close connection method. WebSocket is useful because only one connection needs to be made and communication between the two entities is real time. The main downside of WebSockets for our use case is that we don't ever need to send messages from the client to the server. In other words, we don't need two-way communication. A minor concern of using WebSocket is that it adds some development overhead. It typically requires more code than other methods, and it bars us from using useful HTTP functionality. The other means of communication we considered was server-send events, or SSE. Opposed to WebSockets, SSE uses HTTP to establish a persistent connection that can then be used for one-way communication between the server and client. Here's how it works within the context of Waypost. First, the client sends a request to the server. The server responds, confirming that the connection has been made. The server can now send messages to the client in response to events. A challenge associated with SSE is how to handle dropped connections. Connections can get dropped either when the client surpasses 6 open connections or after 30 seconds of inactivity. We remedied these concerns by making it so the SDK reestablishes these lost connections. SSE works well for our use case, and we ultimately chose it because it allows for real-time event-driven communication. It's simple, and opposed to WebSockets, communication is one way from the flag provider to the SDK. An additional challenge we faced was how we wanted to implement the statistics pipeline. A crucial piece of our architecture was the statistics pipeline. It consists of 3 steps. First, we query the organization's user event database for the metrics being tracked. It then analyzes this data using statistical tests. If all goes successfully, it stores the results in the Waypost DB. We estimated that this pipeline could take a long time if a company had a lot of user event data. So we had to decide how often to run this pipeline and whether it deserved its own server or not. If we ran the pipeline frequently, the developer could quickly access experiment results without having to wait. However, this would take up a lot of computing resources. We realized that frequent updates weren't necessary, given that it's not recommended for experiments to look at results before an experiment is finished. That meant there wasn't a need to consistently refresh results. We decided to implement a button on the experiments page that would run the statistics on command instead. This saved us a huge amount of computing resources. We also timed how long it took with a large data set of about 10,000 users in the experiment with multiple metrics, and there was hardly any delay. Therefore, we decided to keep the statistics feature on the same server as the Manager app. So now that we're acquainted with Waypost and the engineering decisions that were involved, we'd like to briefly mention a few of the features we'd like to include in future versions of Waypost. As Waypost currently exists, applications running the SDK receive all of the flag data regardless of whether the application pertains to that app. In the future, we'd like to separate flags so that applications only receive the flags that pertain to them. Also, we'd like to include a login functionality so that users can add permissions to individual users or groups. This functionality would also allow Waypost users to track who makes edits to the flag data. So thank you for listening to our presentation. If you'd like to learn anything else about Waypost, you can follow these links to either our GitHub page, and our case study will be posted within about a week. So again, thank you so much. We really appreciate it. We'd like to just open up the floor to anybody that has questions about Waypost. So we have one question in the chat. It's asking, in your statistics pipeline, what time of statistical analysis is being conducted? What type? Yes. So what type of statistical analysis is being conducted? I think Julia or Sean could probably speak a little bit better to this than I can.
Yeah, sure, I can take this one. Hey, Lydia. Our statistics pipeline does 2 tests depending on the type of metrics. So there's like continuous metrics, which are things like total, like amount of time spent on site. And so for that, we used a t-test, I believe. And then for the other type of metric, like binomial slash also called discrete metrics. So that'd be like kind of like a rate kind of metric, like a sign up rate or conversion rate. We use a chi-square test for that.
All right, another question here says, so a few questions. Are feature flags the only way of implementing the splitting required for A/B test, or are there other ways? Excellent question. Sean, I don't know if you want to.
I got this. So feature flags are by and far like the best way to do this. Like technically, you could also split with like a canary deployment style. So you would have like one version of your entire infrastructure on one server and like another copy on another server. And then you would route users to one server or another. But with that, you'll have a lot of duplication. You won't be using your resources well. And then I think there's one other way, like an API-based way for A/B testing, where you like a user visits your website and then like some API requests get sent out to put them in the experiment and then like re-render the website. But those are only usually like done for like very small UI changes. So if you want anything big or like an entire new feature, it's not really a good option. And then
I can answer his next one.
Okay.
So on your second question, you asked, could the new version users ever notice that they're being redirected to a different URL or anything like that? This purely depends on how you're implementing the feature flag. And it kind of also depends on how you're rendering these pages. So yeah, that's just like how it all depends. Because if you're using React, you can kind of specify those URLs a little bit differently. So that just mostly depends. Steven asks, does Waypost add any additional load to the existing event database? If so, are there any considerations for users to keep in mind when configuring Waypost in their infrastructure? We can go back around to Julia if you want to answer this.
So it, I guess, is asking whether there's any load added to the, like, that existing event database. So not really. I mean, we're querying it, like we're querying one table, which is the one that's bucketing users into like an experiment of that exposures table. That's getting queried once per day. And we timed it so that it's like in the middle of the night, like once every 24 hours. And it only takes like a second. So it's not really much load. And then the other pipeline, which is querying for the metrics, that also only takes like a second. Obviously, if they have like billions of rows, it could take a little longer, but our product is geared towards small businesses, which we're kind of assuming like don't have billions of users. So, with the amount of data that we tested with, it was very, very quick. So it was not really any significant load.
We have another question here. Could you talk more about how you kept the SSE connection open between the Flag server and the app running the SDK? So I think Julia had a little bit more hand in the SDK and kind of how that SSE connection works. But like, so Julia, you might need to check.
Yeah. So we use the at least in JavaScript, we use the event source API, which does the SSE connection for you, and they actually automatically will reconnect if they like detect that the connection is lost. So that was all handled for us by the API that was baked into the JavaScript language. So we didn't actually have to worry about that.
I think we missed that Wes's last question. He asked us, how do we have time to do all this?
Oh, this is because we have some super incredible coders here.
Yeah, I mean, we went hard for sure, but we based our project off some like existing projects, like Pioneer, which had a feature flag manager. So we were kind of able to see what the gist of a feature flag manager looked like. And then for our A/B testing, we were inspired by a company called Growthbook. And like they showed us how to do the architecture where like you use this separate events database instead of having it in-house. So just using those two and, you know, lots of time spent coding.
Yeah, for sure.
Oh, and shout out to our mentor as well for helping answer our questions. Thank you, Max.
Julio has a question. He asks, when querying the event database to run statistics, does Waypost expect any particular schema for the data? And the answer is yes. It went pretty quick, but yeah, like we do expect it to be in a certain format. Like in the demo that we showed, it was just like a simple select statement, but that's just because our dummy data was already like formatted really nicely. But like in reality, that statement could be pretty complex because they will have to get that into the correct format to work with Waypost. So yes.
Thanks for coming to view our presentation. You know, if you're an employer, feel free to reach out. And thank you to Launch School for, you know, kind of giving us this platform and allowing us to, you know, make something great.